This is now the 2021 Indiana Drought Planning and Preparedness Kickoff Workshop. It was originally the 2020 workshop, but obviously with the pandemic, and we were going to have this in April of last year, the pandemic kind of pushed things away, but now we're in virtual mode. And this is a kickoff workshop. And I'll go into this a little bit more because plans are that we're going to have 2 more workshops, hopefully one in June, one in July, that we have not set the dates for yet, but those will be focused more sub-state, if you will. And at this point, we're thinking a Northern Indiana and a Southern Indiana. But before we started to take these kind of regional road trips, if you will, around the state, we thought it was important to have a kickoff workshop to get all of us on the same page before taking this down to a more local scale. Now I need to, so why are we here? And I know you've probably seen these goals and so forth and the emails and the agendas, but I just wanted to reiterate that certainly appreciate your time. I know there's so much Zooming going on, so much multitasking, that to ask you to take your time out over the next 3 mornings to be a part of this group and participate, it's asking a lot in this day of Zoomedness. But there is a reason why we've asked you here. One is to identify really where Indiana is at with the understanding, planning for, mitigation efforts, and responses to drought in a coordinated effort. A lot of times different agents, we have a lot of representation at this workshop from different agencies, even different states. And are we working together? We might have our own drought plan. We might have our own way that our program or agency responds. And we thought it would be good to try and get everyone together so that we're on the same page. We understand what are the issues, who's doing what, where are the roles, so that we can coordinate better. There are 3 main objectives to this workshop. One is to identify what Indiana knows, doesn't know we know, et cetera, about drought preparedness, and drought early warning. We want to get everyone from state, federal, key sectors, local, municipalities, universities coordinated for drought so that proactive steps can occur to minimize adverse impacts of drought. And in that sense, we are trying to be proactive, not reactive. We're trying to get ahead of the game and get everyone on the same page. And then the third objective is to understand the importance of water in the state. So not just thinking about, oh, is drought developing? Is it getting worse? But how are we respecting water in the state, either from an agricultural standpoint, from a quality drinking water standpoint, just availability. The anticipated outcomes. So hopefully by the end of the workshop on Thursday, as we're heading off to a late lunch, is that we all have a common understanding of drought and drought needs in the state. We have a common understanding of documents and planning resources that currently exist, and for that matter, perhaps those that we don't have but would love to have. And maybe at this point, we just can't tell you if drought's going to start to really get bad on June 1st, but boy, it would be nice if we knew that. And then finally, an increased collaboration with partners at the state level for drought planning and mitigation, which really is a key goal that we have for this workshop, and that why you are all here is so that when this ends, we get to know each other a little bit better. So as we're thinking proactively about drought, we almost already know who to pick up the phone and call. This workshop, like I said, has been in development stage for over a year now, and I want to introduce you now to the wonderful planning team that was involved in making the workshop what it is for you guys the next 3 days. This is in no particular order, but actually it sort of is, because I had square pictures for the top row and elongated portrait pictures for the bottom. But we have Manuela Johnson from the Indiana Department of Homeland Security. She's the Administrator, State Disaster Relief Fund. We have Ryan Mueller, who is with the Indiana Department of Natural Resources, Division of Water. He's the Director. Hans Schmitz, who you just heard talking, he's with Purdue University. He's an extension specialist and really a Zoom master. He provides a lot more than just knowing everything about Zoom, but he's been wonderful with these workshops. Molly Woolison is with the National Integrated Drought Information Services, otherwise known as NIDIS. She's also the Midwest Drought Early Warning System Coordinator within NIDIS. We have David Smith of the Indiana Department of Natural Resources, Division of Water. He's a water resources planner. And then my name is Beth Hall. I'm with Purdue University, and I am your Indiana State climatologist. General agenda that we're looking at over the next 3 days. So today, or this morning, really, it's just laying the groundwork of the situation in Indiana. But more so than that, it's just drought in general and how is it going to be impacting. So we have, what is drought early warning anyway? Molly will be talking about that briefly, particularly from the perspective of NIDIS and the NIDIS Drought Early Warning System. Then we'll have a little Drought 101, just reviewing the different components of drought. How do we know when it starts, ends? Are things changing in recent decades regarding drought in Indiana or the Midwest in general? We're going to have some presentations about the importance of water across the state, some focus on the Central Indiana Water Study. And then we're going to finish the day looking at different drought responses and preparedness, both what we know we have going on in Indiana, but also what other states are doing. So we can start thinking about, well, is there anything that we want to perhaps change as a state? Are there good things that we have going on? And then that will get us into day 2, where we will have a little bit more in-depth discussions of when there's been drought in the past, what were those impacts? Who is impacted by these? How quick did it develop, so that how quick did we have to respond? Do we need to prioritize these impacts? And what are the challenges of addressing these impacts so that we can start thinking about the challenges and coming up with solutions ahead of time? And then how do we bring all of this together when we start translating what we're talking about this week into those more local communities later this summer? And then finally, on the third day, Thursday morning, we'll be looking at decision support resources and tools that are out there, because some of you may know about this great resource that is out there, and some of you may never even knew that some of these tools existed. So it'll be an opportunity for different programs and agencies to go over these tools and resources. A time for us to think, is this enough? Have we captured all the information we need to make good decisions? And then where do we as a state go from here? All right, you've heard me talk for way too long. We're going to do a quick icebreaker before we move into Molly talking a little bit about NIDIS. So here's my ask of you from your phone, your smartphone, or if you're doing a tablet or a desktop computer, and you have the ability, go to a browser page and go to www.menti.com. And then you'll enter that code. Now I'm going to escape from this screen and you're going to be like, oh, I didn't get that code. How dare you? That's okay. That's okay, because I'm going to try to show you the code again. Oh, I need to stop sharing though and share my Chrome. All right, so does everyone see a screen that looks like at the very top it says go to Mentimeter? Perfect. So on your phone, people are picking this up. Just enter, what is your favorite hobby? We got gardeners. Oh, archery. I'll have you know, I won the gold medal in archery in a corporate challenge event in Reno, Nevada. You might think that the competition wasn't that hard, but I'm proud of that gold medal. Cooking, video games, fly fishing. I think of, is that a river runs through it? I see running big and center, which it's a word cloud. So the bigger the word and the more central it is, that's the more popular. So we have a couple runners in this group. I don't know if you all know each other. I was gonna say, I thought I saw sleeping, and I like that one. Avoiding running. Okay, now that person is speaking to me. So kind of a fun, broad spectrum. I was just seeing an article yesterday that more and more hobbies are are gaining popularity with the pandemic, and it's kind of similar to the Great Depression. But unlike the Great Depression, where people could socialize and gather, and the card game of bridge became really popular during the Great Depression, we're so isolated that our hobbies these days are almost more solitary in nature than the more social but cheap in nature from the Great Depression. Crochet. Ah, now someone's speaking to me. I'm a knitter and crocheter. Gardening's beating out running. All right. I'm going to move on to the next question just for the sake of time. So I think I'm surprisingly doing okay. Oh. What is the worst job you've ever had? And keep it clean. Detasseling, I've heard that can be pretty horrible. Wow, shoveling metal dust off a roof with heat indexes of 1,000,000 degrees. Boy, I'm hoping the screen scrolls. Oh, I have to scroll it. Scooping ice cream. That's funny because every time I go to an ice cream place, they look so happy as they're scooping out that cookie dough for me. Cleaning up vomit. Oh gosh. Yeah. Some of these are kind of horrible. Though we started off with a strong retail theme, things are getting a little bit more like dirty jobs. Huh, pouring concrete. Oh, county parks. I'm on the last season of Parks and Rec right now. I've fallen in love with that series. All right, I don't know if everyone's had a chance or if they're still thinking, because every job they've had has been just wonderful. Scroll up so you guys can see what other people have said. Paperboy. I would think that's got to be horrible when it's raining and snowing outside. Okay, I am going to try to escape out of that. See where my world is. Oh, sorry, that's my dog. And if I do this enough, then all right. Can everybody see the presentation back about nidus?
Yes.
Cool. So now I'm going to head over to Molly to say a few words about nidus, and also big thank you to the nidus program because they are the sponsor for this workshop.
Great. I'm assuming you can hear me okay?
Yes.
Okay.
I'm just going to go on mute because of those darn dogs.
Yes. Hi, everyone. As Beth said, my name is Molly Wolozin, and I am the Regional Drought Information Coordinator for the Midwest Regional Drought Early Warning System. And I'm with NIDUS, which is the National Integrated Drought Information System. We are a part of NOAA, but we have been authorized by Congress to do the work that we do since 2006. And we've been reauthorized twice in 2014 and 2018. We have an interagency mandate to develop and provide a national drought early warning information system. Essentially, our goal is to help our country move from a reactive state to drought to a more proactive approach, really with an end goal of reducing drought risks and impacts across the country. An important part of NIDUS, as I said, is that we really are an interagency. So even though we sit within NOAA, which is the National Oceanic and Atmospheric Administration, We work with all different federal agencies, state agencies, tribal nations, local partners, as well as those in academia, the private sector, and others like citizen scientists. And just to give you a little bit, let's see. Oh, Beth, could you advance? I forgot I don't have the controls. As I mentioned on the previous slide, NIDIS has been authorized to develop a national drought early warning information system. So just to briefly kind of step back and think about exactly what is a drought early warning system, I find that it's helpful to look at the definition of drought early warning. So early warning is the provision of timely and effective information that allows individuals that are exposed to a certain hazard to take action to avoid or reduce their risk in order to hopefully reduce impacts and prepare an effective response to the hazard. When we look at this in the context of drought, what are those pieces of information that we need in order to make these better decisions to reduce our risk to drought? The figure on this screen shows the 5 components or pieces of information that are really key to a drought early warning system. And that is looking from observations and monitoring, predictions and forecasting, planning and preparedness, communication and outreach, and also interdisciplinary research and applications. So even though a drought early warning system might sound like it's just getting an advanced warning of drought, which that is definitely a big component of it, it's not the only thing. Really, it's showing that what's important is having systems in place in order to monitor drought, be aware of what the outlooks are for drought, having effective plans in order to effectively monitor and incorporate different agencies into your response effort, for instance. And also communication and outreach is a big piece of having a drought early warning system. Whether that is from NIDIS to the state level or the state level to other partners, that's a really important piece. And I'm sorry if you can hear the garbage truck outside my house right now. The joys of working from home. And then finally, the research piece is really important too. It's really important that we understand the best research, especially as we look at different regions like the Midwest, understanding the characteristics of drought and the best ways to prepare for drought. And you'll hear a little bit more about that later on, and then when I talk later this week. Oh, Beth, could you advance, please? So NIDIS, as I mentioned, has a national, our goal is to have a national drought early warning system. We have taken the regional approach to develop this national system though, because obviously climate and drought are very different from one place to the next. Drought in the Midwest is much different than what we see out west. And so we have to date, we have 8 early warning systems. We are currently making our way to cover the entire country. Hopefully that will be something we are able to do soon, because you can see the white states. We do have some states that don't technically have coverage, even though we do still support drought services in those states. But really what's key about the drought early warning system is the network of people. So Indiana is in the Midwest Drought Early Warning System, and we work with 8 different states across the Midwest. And the real value of the Drought Early Warning System is the network of partners. Again, from the federal, state, local, tribal level, academic partners, the overall goal is to make climate and drought science accessible and useful for decision makers to be able to better plan for drought. So I think I will stop there. Beth, I believe that was the last slide I provided you.
Sorry, trying to find the mute button. Yes, I think it was. Okay. Thank you. Yeah. Okay. So thank you, Molly. If anyone has any questions for Molly, just because we're running a little behind and I still want to do 2 more Mentimeter questions so that we can get to know each other, please feel free to put a question in the chat for Molly, and she'll be watching that as the Mentimeters are going on. So while Trent is up next. Before he shares his screen, like I said, I want to do a few more of these Mentimeters. So again, pull out your phone or tablet or whatever you were using. The website is the same. The code is the same. And how do I... There we go. So the next question, because remember, one of our goals is so that we can get a better feeling for each other, know who all is here at the table. If you don't mind filling this out, so we kind of have a fun way of knowing who is here. So one person is with emergency response. Oh, here we go. And you can kind of see the makeup. You know, and we, back in the day, years ago, when we would actually meet in person, we would actually go around the room and introduce ourselves and say who we're with. But this is how things have changed in our world. So interesting with the public awareness, a lot of people. Regulatory enforcement. There we go. We got waterway navigation in there. If you're someone who said other, can you put in the chat box what the other is, just so we can enjoy learning more about that? Providing resources. There's 10 people who said other. Oh, but maybe you're like, I can't do both. I can't do Mentimeter and Zoom at the same time. Mitigation planning. Hi, Dennis. Providing drought impacts. Great. NDMC is here. All right. I am going to try and go on to the next question then. What are two different words that best describe drought to you? And this is going to kind of kick us off, mentally get us engaged now for Trent's presentation. Education, Bob. Coordination, Allison. I see stress. I don't know if that's vegetation stress or just personal stress. I can't take this anymore. Vague. Nosebleed. Scary. I love watching these unfold. There does seem to be a common word, though. Dry. Absence. Complex. Sneaky. Ooh, Trent will have to talk about the sneaky aspect if he can. Very good. So beached, nosebleed, hot, lack of water, complex. Well, I'm going to end on the complex note and stop sharing. And Trent, if you want to start sharing. Yeah. So I think we're at that point.
Okay. Can you see it okay? Good.
I see it in edit mode. Now I see it in presentation mode.
All right.
Good job.
Yeah, so I'm gonna start the timer so I don't blather too long. So thank you for inviting me to speak today. So it's called Drought 101, but and I have some kind of basic information about drought that most of us probably understand already that I'll get through pretty quickly. And then also I want to talk about recent research into sort of drought climatology for the region, Indiana in particular, but the Midwest region as a whole, and then changes in the characteristics of drought both over the past several decades as well as projected into the future. So any good professor starts their talk with a rhetorical question of what is drought? Fortunately, this image here is not from Indiana. It's actually from the Brazos River or what was the Brazos River in central Texas in 2011 when I was living down there through a pretty intense drought, equaled actually what they're dealing with right now. And in general, really the only bullet point I would say that could be that could properly answer this question for everybody in the room of what is drought is that it is associated with water shortages or lack of precipitation. This is sort of the point of asking this question in the first place, because everybody here that's listening now is thinking to themselves what drought means to them. And in fact, none of you are incorrect. And this is really one of the premier challenges of drought, and really separate drought from all other weather-related hazards in that it's relative. And that's my third bullet point there. Drought is relative, and that adds a tremendous amount of complexity. So drought is relative. I have a picture here of a suburb of Las Vegas on the left and the Bienville National Forest on the right in Mississippi. Drought means two very different things to those two regions. But even within a region, even within the state of Indiana, even within one county in Indiana, for example, drought is relative to the person who we're talking to. And so how one is impacted by drought, when one is impacted by drought, really makes for how one defines drought. So a farmer in Tippecanoe County will define drought based on how they're impacted, and that would probably be different than a water manager or county manager in the same area. What that means is that it's a challenge to define, okay? And that is really the premier challenge is defining drought so that we can properly measure it, understand its impacts, and all of that comes from the definition. The challenge in the definition, the challenge in the fact that it's relative also makes it difficult to monitor the onset, the evolution, and demise, right? So, for example, whether or not the hurricane hits your house and destroys your house or destroys your land, the hurricane happened. But if a drought doesn't impact you, did the drought happen? That is a question that really probably can't be answered at this point, but that's, again, makes it difficult to monitor the onset, because the onset itself for a drought, the evolution of the drought, and then the end of the drought is different for different folks. So in northern Indiana right now, after going through pretty significant drought last year, there are probably places or sectors that believe they are out of drought. Because perhaps their stock pond has come up, perhaps they have enough soil moisture to get through the growing season and they're good to go. But folks who maybe have a longer time for drought evolution may not feel that they're out of drought yet, even in the same region. So this all provides quite a challenge for understanding drought. And again, this isn't just the NDMC where they're trying to monitor drought across the whole country. This is just even within one region. So, despite all of that complexity, trying to find different ways of defining drought and really coming up with this basic categorization, 5 general drought categories. The first is meteorological drought. And you can see for under each of these, I bold the sort of indicator that is most commonly used to identify that type of drought. So the meteorological drought, that's that period of time with below normal precipitation accumulation. The period of time here, again, is relative depending on the impact. So it may take a relatively short time period of below normal precipitation to affect crop yields, probably a relatively longer time period to affect water availability for municipalities or industry. Agricultural drought is a period with soil moisture deficiency. Typically what we see is meteorological drought persist for a number of weeks to months, in some cases several months, before we see soil moisture begin to be affected by that. Now, the last category here I'll talk about in a little bit, that's actually kind of turning that idea on its head to say that soil moisture can respond rather quickly to even short terms of below normal precipitation. Hydrological drought is a period of groundwater or stream flow deficiency, where you begin to see impacts in water availability in surface and groundwater. And then socioeconomic drought is a bit of a catch-all. That's when drought impacts the result in effects on people through the availability of economic goods. So food, water, fuel, et cetera, that's a socioeconomic drought. So a drought can be a meteorological drought. And if it impacts, for example, crop prices, livestock prices, something like that, it's also a socioeconomic drought. And then we have ecological drought, which is prolonged widespread deficit in the naturally available water supplies. That creates multiple stresses across ecosystems. The reason that this is important to separate from agricultural drought is because a lot of the indicators that we use to understand agricultural drought are fine-tuned for agriculture and not necessarily for natural ecosystems. So when we think about, for example, drought in the wintertime, which I'll talk about a little bit later, a lot of times when we think about agricultural drought, folks tend to fall off in the wintertime because we don't have a lot of active agriculture going on in the Midwest. But in fact, a wintertime drought or persistence of drought throughout the winter can have ramifications for natural ecosystems, especially when we start waking up in the spring. And so having that ecological drought is really important. And then we get to this last one. And I don't have a number next to this last one because it's really not, it's a separate drought category, because arguably any of these types of first 5 droughts can be a flash drought. And that's a drought that begins or intensifies rapidly as to reduce preparation or early warning time. I'll talk about this in a little bit. The idea of a flash drought has really spun up very quickly since around 2010, 2012, since we had the 2012 drought. And the research is still ongoing as to what causes flash droughts, how often they occur. But what we do know is that what really characterizes a flash drought is rapidly deteriorating conditions that cause impacts faster, not necessarily larger magnitude impacts, but impacts faster as to reduce early warning and preparation time. Okay, so what are things that indicate drought in Indiana, right? And this can be different in different states. Generally speaking, this is across the Midwest. Precipitation, of course, that's really where it starts. Yeah, monitoring and indicating precipitation issues, right? But we have below normal precipitation of this magnitude for this period of time. Also, we need to understand not just what's going into the ground, but also what's coming out through evapotranspiration and evaporative demand. So how much evaporation and transpiration is the atmosphere taking back, which can be important, especially in the warm season. And that's really where we talk about flash drought. You know, a lot of the research suggests that flash drought isn't just an effect of precipitation, but the combination of below normal precipitation and strongly elevated evaporative demand. So we have a large water balance or imbalance. Soil moisture is an important indicator. Really, it's a sort of an integrator of what's going in, what's coming out. And that's really where the rubber meets the road as far as vegetation, whether it be agriculture or natural resource impacts. Stream flow and groundwater are really important indicators for hydrological drought, as well as reservoir or surface water level. Snowpack, of course, this is more relevant in northern Indiana than in southern Indiana, but having snowpack that can persist into the early spring and melt slowly, that can provide a sort of boost or lag effect of winter precipitation on soil moisture and stream flow, of course, in the northern part of the state. Whereas some or springs where we don't have that snowpack persisting, for example, that was a big impact in 2012 where we didn't have snowpack pretty much across the southern 2/3 of the Midwest. That can actually exacerbate dry conditions if we have soil dryness going into the spring. Then, of course, vegetation health and productivity is a real good bellwether for how natural ecosystems and agriculture are responding to prolonged dry conditions. And then really importantly are impact reports. So the first really few bullet points that I mentioned here are physical indicators, but it doesn't necessarily tell you how folks are being impacted or what folks are seeing on the ground. And especially when you're trying to monitor drought across a state like we do here in Illinois, you all do in Indiana, impact reports from folks in individual counties and townships and regions can really make a difference as to how we perceive a drought intensity. I will say, though, this bold italicized, there is no single indicator that properly summarizes all drought characteristics. So I'm going to shift a little bit to drought characteristics, but it is important to say that we can't just focus on precipitation. As much as I want to, we can't just focus on soil moisture or snowpack. It's really this integrative assessment of how drought happens. And I think that David Manuela, who put together the weekly monitor report for Indiana, do a really good job of going from precipitation through soil moisture to reservoir levels to vegetation health and going through all of this to assess exhaustively and physically what's happening as far as wetness conditions in Indiana are concerned. Okay, so moving to some climatological drought characteristics for Indiana. Most of these are going to be statewide, but I do break it down by region a little bit. So talk about drought frequency. What I'm showing you here is monthly Palmer Drought Severity Index for the entire state. All right, negative values of PDSI indicate a negative water balance. Values less than -1.5, -2 typically indicate drought, and values less than -4 indicate extreme drought, whereas positive values indicate overall moisture surplus. So what we see here is a lot of variability. Indiana is no stranger to drought, especially when we go back to the 1960s, 1950s, 1930s. We see these prolonged multi-year periods of pretty extensive drought. However, really since the late 1960s, we've seen a regime shift to overall wetter conditions. We've still had drought in the recent period. We can think about 1988, 2012. But actually what was really impressive to me, focusing on Illinois all the time for myself, I didn't really know this, but statewide, Indiana has not had a month where the PDSI has been below zero since November of 2013. So we're going on almost 8 years of consistently wet conditions statewide. Now we break this down by region, especially from last year, we see that certain regions have suffered from drought. The PDSI has dipped below zero. But when we assess Indiana as a state, we really continue this really unprecedented period of wetness that at least going back to the late 1800s have not seen previously. We can also think of drought frequency as sort of a return interval. Now, I should say this is not a publishable figure. First of all, it's quite ugly with the colors put together, but also this is a back of the envelope calculation of return intervals. This is just basically saying how many years of records do we have? How many of years do we see that the ranking of these different events? But what I do is I kind of do a back of the envelope calculation of the return interval, the rarity or the frequency of some historic droughts in Indiana's history, 1954, 1988, and 2012. And what this is showing is the return interval of the driest 3 months in that period of time. So think about a seasonal drought, right, that can really have an impact on natural resources, agriculture, water resources. The driest period in those years, what's the return interval of something like that? What I'm showing you here is the return interval for the driest 1 month, 2 month, 3 month, all the way to a 24-month period of time. What this is showing is that the return interval of the driest 1 or 2 months in all of these three drought periods is relatively small. We think about 2012 and the impacts, the 2 driest months, or the driest 2-month period in 2012 has a return interval of less than 5 years, right? However, once we get up to this 3 to 6 month interval, that's when we begin to see how rare these sorts of events actually were. What that means is that it's really more of a reflection of the climatology of drought in Indiana more than what these events actually were, what these individual events actually were. What I'm pointing at here is that having a very dry 1 or 2 or even 3 month period of time, like 2012, actually happens relatively frequently in Indiana. What doesn't happen so frequently is getting the 6 to 9 to 12 month periods of time that prolong that dryness. And I'll show you that here in a little bit in a different way. But basically, when we think about drought frequency in Indiana, the frequency decreases as we get as the duration of the drought increases. So overall, having a prolonged 6-month drought like we had in 1988 and 2012 is relatively rare, but having a 1 or 2 month very dry period of time like we did in 1988 and 2012 is actually not so rare. I throw in 1954 here because you can see that the return interval for 1954 sub 12 month is actually not all that infrequent. However, when we talk about the 1950s, especially the mid 1950s in Indiana, it's really this longer time period where we begin to see these longer return intervals. And that's because, again, having a 1 or 2 month dry period on the record is not very infrequent. It's not relatively rare, but getting prolonged drought for more than 9, 12, 24 months is actually quite rare in Indiana's record, and really for most of the Eastern Midwest. All right, so moving to drought onset, what these maps, this is from a paper that's in review now that was led by Andy Howlett at NOAA. And what they show is the seasonal frequency of drought onset across the Ohio and Mississippi basins for Huck 4 watersheds here. What this shows, the darker reds and oranges show seasons where drought onset happens climatologically more frequently. The lighter colors are less frequently. So overall, drought onset for most of Indiana is most likely in spring, March through May, in all pretty much, but Northeast Indiana. Northeast Indiana, it's a little bit more frequent in summer and fall. Winter onset for drought is unlikely in all but the very far southern parts of the state. But overall, climatologically, drought onset is most likely in the spring. And the reason being, and this is really pointing to variability. Winter precipitation variability is not very large relative to spring precipitation variability. And so we can get very dry springs here in the Midwest that cause drought onset, whereas drier, wet winters really don't have as large a magnitude, so we don't get the onset in those seasons. Similarly, these maps are showing the frequency of drought demise across the Midwest. Again, the darker blues indicate a higher frequency of drought demise. Again, we're seeing the highest frequency of drought demise or ending of drought in climatological spring, the lowest in climatological winter. What this means is, this is really important, again, as we talk about agricultural and ecological drought. If we have drought going into the winter, it is very likely throughout much of Indiana that we will persist that drought into the spring. It's what we saw this year. It's very rare that we'll get drought demise in the wintertime. Why? Because the winter months, although we associate them with a positive moisture balance because there's not a lot of evaporative demand, our winter months are our driest months in the Midwest. And so therefore, it's very unlikely we're going to get enough precipitation and that it's not going to run off because of frozen soils to really help out to see drought demise. So this is important when we think about drought monitoring in the wintertime. A lot of times some of these products and folks kind of shift away from drought in the wintertime because, again, often the soil tends to be pretty wet. However, monitoring for changes in drought in the wintertime can be really important, especially as we transition from winter to spring, where we see the highest likelihood of both drought onset if we're coming out of a wet period and drought demise if we're coming out of a relatively dry period. And then thinking about duration, these maps show the frequency of drought by duration. So the darker purples and reds show a higher frequency of droughts that last at least 2 months, at least 6 months, at least 12 months, at least 18 months. So what this is showing is that less than 5% of droughts in Indiana persist for at least 6 months, less than 1% for at least 12 months. And they're actually in these Huck 4 watersheds in the 70-year period of this study, there were no droughts that persisted for 18 months. And this is getting back to that return interval that I showed you before with the 2012 and 1988 droughts. It's not really all that rare that we have a 1 or 2 month or even 3 month very dry period in Indiana. But for that to persist for 6 and especially to 12 months and beyond is actually quite rare. And the reason being is we do have a pretty wet climate here in the eastern half of the Midwest. And so it's rare that we get significantly below normal precipitation for that period of time. It's much more common to have those sorts of longer persisting droughts farther north and west, where they can get into a bit of a drier regime more frequently that can persist for a longer period of time. This is just another way of showing that. No need to focus on the statistics here for this plot. Basically, what I want to say is that only 11% of droughts that cover more than 50% of the Ohio basin. So we think about drought extent. When droughts cover more than 50% of that Ohio basin, so a large, spatially extensive drought, only 11% of those have persisted beyond 1 month. So, one of the notable things about 2012 that I didn't mention in that return interval plot was how spatially extensive the drought was. We can contrast that with last year's drought in 2020, where it really only affected a small area from central Illinois up through north and central Indiana, where southern Indiana pretty much stayed relatively wet. 2012 wasn't like that. Pretty much from all the way from Wyoming through Ohio, we had pretty significant drought. But those droughts, when they do cover that large area, they tend not to persist very long. And again, that's because, especially here in the Eastern Midwest, we tend to not stay in a very wet or very dry regime for a relatively long period of time. Okay, so real quick, I want to get to some of the changes in drought, but Beth asked to talk a little bit about drought causes in the Midwest. In general, drought in the central U.S. is caused by ridging throughout the atmosphere. So that's elevated geopotential heights. The atmosphere essentially expands, and we get high pressure at the surface. And that high pressure allows or is the result of sinking, slowly subsiding air, which makes for very stable conditions. So especially in the warm season, when we depend on vertical uplift and instability to generate a lot of our precipitation, we tend not to get that. Those high pressure systems can be quite insidious because they can actually persist for a relatively long period of time and set up blocking highs, which can actually not only create warm, sunny, clear conditions, low humidity at the surface, but also can stop or impede incoming low pressure systems that could bring relief in the form of rainfall. And so when we get one of these blocking high pressure systems set up, especially in the summertime, that typically means we'll see dry conditions. And if those atmospheric conditions persist, which they can for quite a while, then we get those relatively long form droughts. Because I'm a soil moisture guy, I just have to mention this. The plot here on the right is showing the relationship between summertime maximum temperature in Indiana statewide and summertime precipitation. We see a significant negative relationship. And I show some years there just to get your mind thinking about, oh yeah, that was a pretty wet and cool or hot and dry year. In general, our driest summers tend to be our hottest summers. The reason being is that once that soil dries out, all of the energy that it gets from incoming from the sun is going to increasing the air temperature, not to evaporating water. So that increases the maximum temperature, although that can also feed back to the atmosphere. So when we get in the lower level of the atmosphere, when that soil moisture provides energy in the way of heat, the soil provides energy in the way of heat, what it can do is that can actually reinforce that high pressure system, that ridging, and actually persist it in place. There's actually a few studies that suggest that 25 to 40% of drought persistence in the Midwest, not onset, droughts onset are an atmospheric forcing, but drought persistence, 25 to 40% of that drought persistence in the Midwest is attributed to a soil moisture feedback. So once we get, especially in the summertime, those dry soils, it can actually allow for those very persistent droughts that we've seen especially in the early part of Indiana's history. Okay. So the big question that you probably wanted me to answer from the get-go is drought changing? What I'm showing you here on the right-hand side, these are really busy plots, but they're actually pretty simplistic. Anywhere you see blue, that's where the annual maximum, the annual median, and the annual minimum wetness across the Midwest is increasing at 1 month, 3 month, and 6 month intervals. So basically the top left plot shows the annual 1 month wettest period of time, the annual 3 month wettest period of time. The bottom left plot shows the annual driest 1 month period of time. Anywhere there's blue, i.e. pretty much the entire state of Indiana, that's where both the maximum wetness and the maximum dryness are increasing. So what we're seeing in Indiana, pretty much throughout Indiana, is that at all time intervals that we study here, 1, 3, and 6 months, the entire climate is getting wetter. Now, the annual maximum wetness is increasing a bit more than the annual minimum, but in general, we're not seeing this. There's also often this trope that comes along with climate change that say the wets get wetter, the dries get drier. That's not happening in Indiana, all right? Or throughout much of the Midwest, that's not happening. We're seeing that the wets are getting wetter, but the dries are also getting slightly wetter. So the entire distribution is shifting. What that means is there's an overall lowered risk of especially persistent and prolonged drought. However, great news. Hey, I can be done, right? Except that we're also seeing a bit more variability. This is a figure from a recent paper we did that was just published earlier this year that talked about these transitions. Also, they're called swings, or some folks call it weather whiplash. I think it's a bit hyperbolic, but these swings between extremes. So how quickly do we go from a wet extreme to a dry extreme, or a dry extreme to a wet extreme, right? We can think about that like 2019 to 2020. 2019, we would have paid a lot of money to have a prolonged dry period, and then we switched to 2020, and parts of Indiana were very, very dry, right? And so these plots are showing trends long-term trends over the last 70 years and how quickly we go from very wet to very dry. Anywhere you see red, that's where we have significant decreasing trends, meaning that the wet to dry transitions are getting faster, okay? At 1 month, 3 month, and 6 month intervals. Across Southern Illinois and into most of Indiana, all but the very northwestern corner, we're seeing significant increases in the speed of how quickly we go from wet to dry, okay? Now, you have to frame this in what I just showed you before, which saying that overall, we're getting wetter in Indiana. However, when we do get dry, it happens faster. So we have to think about what this means for drought preparation, drought early warning, okay? When we're focusing on what metrics we're using to monitor for drought, we need those indicators and metrics that can respond to rapid drying. And this is where kind of flash drought comes in again, when we're thinking about how quickly we can go from, hey, everything's great, we're actually excessively wet, to, hey, we're pretty dry. Okay, so last piece here is, great, you showed me what's going on over the last 70 years. What about the projections? What about the next 70 years, right? What I'm showing you here are projected changes in extremes from CMIP6, downscaled CMIP6 models, essentially climate models showing projections in Indiana. The top plots, A, B, and C, show projected changes in the annual maximum. So how wet does it get in any given year? The plots on the bottom, D, E, and F, show the projections in the annual minimum. Anywhere you see an increasing trend, that's where the wet or the dry extremes are getting wetter. At 1, 3, and 6 month intervals from left to right. Again, in general, the projections indicate this continuation of increasing wet extremes in Indiana at 1, 3, and 6 month periods. The dry extremes are projected to increase in intensity at 1 month, but decrease at 3 and 6 months, meaning dries the projections show dries could get drier at 1 month intervals, so a dry 1 month, but 3 and 6 months are actually increasing. What does this mean? What it is pointing to, these models are pointing to overall wetter conditions into the latter half of the 21st century in Indiana, superimposed with more extreme short-term variability. So you can imagine a summer where we get overall wetter than normal conditions in the summertime, but one of those months in that summertime was very, very dry. Okay, not completely unlike what we had in 2020 in some parts of Illinois and Indiana. This is the last part I wanted to focus on is the projected changes in seasonality, because when your wets and your dry periods occur, that can make a difference. These maps, these plots here on the right-hand side, the blue and the black lines show observed monthly frequency of annual maximum and minimum standardized precipitation between 1950 and 2014. And so basically it's showing when does our wettest period, when does our driest period occur? Now, I will say April to June is always, or not always, but is most of the time climatologically going to be wetter in Indiana than December through February. However, this is accounting for climatology. So it's a relatively wet January, a relatively wet February, so on and so forth. What the black line, the blue line are showing is basically flat line, which means that when we're accounting for climatology, we have an relatively equal probability of getting our wettest time and our driest time any time of the year. Okay, there's not a distinct seasonality as what we have in some drier climates, for example, or monsoonal climates. The red line are showing projected changes from CMIP6 over the period 2050 to 2080 in the occurrence of those annual maximum and annual minimum wetness. Basically what it's pointing to is more frequent annual maximum wetness in winter and early spring, and more frequent annual maximum dryness in summer and early fall. So the models are projecting an increased likelihood of getting this wet spring, dry summer transition. And this is not just for Indiana, it's throughout. I have to deliver the same kind of bad news to Iowa later on today. Throughout the Midwest of this sort of movement from very wet to very dry. And that's what the models are projecting here. Now, these are model projections. We're projecting or trying to guess the future here. So of course they come along with some uncertainty, but it is something to keep note of, that this change in seasonality, although when we average it over the course of the year, Indiana is getting wetter or is projected to continue to get wetter. However, the seasonality of precipitation does matter as far as the impacts to different sectors. Okay. lots of information. I probably went over my time, so I just apologize to Beth ahead of time. Here's my summary. I don't need to read all of these points here for you because we kind of went over all of them, but I do want to point out my contact information here. I know I work for Illinois. I'm across the border, but we all want to work together here in the Midwest. So if there's anything that's relevant or any time you have any questions or anything, please feel free to reach out to me. And I'm always happy to talk with folks, even if they're not in Illinois. So Beth, thank you again for letting me talk, and I'm happy to take any questions.
Thanks, Trent. Hopefully everyone now understands why I asked Trent to give this talk as opposed to me. He is nationally recognized for his research and understanding of drought, and in particular soil moisture, and is really that go-to person in a lot of cases when I have questions about drought. And I know for the Purdue Mesonet this year, we're installing a bunch of soil moisture sensors. So I've been working with him on that. And we have a flash drought study going on in Indiana. So I thought, instead of me trying to do this, Trent really is a great presenter. And thank you again, Trent, for doing that. For a lot of you, if you just have lots of questions or want to see his slides or have them emailed, private message Trent, but we probably can squeeze in 1 or 2 questions if anyone wants to raise their hand or unmute, or just put it in the chat box, and then Trent can look at that and try and address before we move on to the next presentation. I know there are a couple comments in there, but folks have been answering them for you. It seems a little quiet, but I know that people are like, well, I don't want everyone to see my question. I don't know what to do, but certainly continue if you have questions for Trent. I think you'll be sticking around for a little bit longer. You can watch it and help answer it, or email him. In the meantime, let's move over to Jack Whitman to give us a presentation on the Central Indiana Water Study.
Thank you. Beth, I really appreciate it. Let's see. That was a fantastic presentation, Trent. It was a perfect setup for this story. My name is Jack Whitman. I'm really presenting for the three of us, or 4 of us: Eric Anderson, Teresa Landaway, and Sarah Hudson is also on the phone, and she's with the Finance Authority. So I'm going to be talking really about the hydrological drought and the characteristics of water availability that we were able to evaluate and describe in Central Indiana. I want to make sure that you know that the purpose of this was really, it came out of a state, the Senate Enrolled Act 416, which basically required an investigation of water infrastructure needs and solutions, and looking at regions. So this region was identified early on, and this was the area of the state that the work was done. And beyond that, we also had a lot of participation from stakeholders and teams of scientists in different organizations within the state, different institutions of the state. So we had the Department of Environmental Management, we had people from IU, from the Geological and Water Survey and the DNR, as well as others with the USGS, et cetera, and Power Results. So we had a group of people were watching this work as we proceeded. And the study itself had 5 different phases. The first phase is about regional water demand. Just what will this region that of the state, the Central Indiana region, what will the demand be in the future? And then some data was, a separate phase was identified for new data collection, and that was being done mainly by the Geological Survey and the US Geological Survey and the Indiana Geological Survey. And then water availability modeling was the third phase. I'm going to be speaking about phases 1 and 3. Phase 4 was dropped because of the kind of the character of the outcome, and public education and outreach also was part of this project. The first thing I'll mention is that there's a 30-page executive summary of this work. I'm going to try to, there's a 30-page executive summary of the 2 phases, phase 1 and phase 3, that you can get from the Indiana Finance Authority webpage. And that kind of has the full description of an executive summary of what we found. And the area that you're looking at is the 9-county region in the state where the work was done. So you can go to that if you want. And there are 2 other reports that are the reports for phase 1, the water supply needs, and phase 3, the Central Indiana Water Availability Report. So the first thing I'm going to talk about really are the methods and the findings of what the future demands will be, the future water supply needs. And the techniques that were used were standard techniques for projecting future demand based on the DNR's Significant Water Withdrawal Facilities database. There's this 30-year record that we have in the state of monthly water withdrawals that the DNR maintains. And that information includes what the water is used for in one of the categories of use: public supply, agricultural irrigation, industrial self-supply, et cetera. And we projected those forward based on a kind of a unit use coefficient method, which mostly tells you what it is, but it's basically a set of regression equations with variables that can account for changes that alter that demand. So temperature, precipitation, household income, all these things affect how much water is being used by the water user in the world. And we projected each of those from 2020 to 2050 to look at the future demands throughout the region. The analysis, we looked at seasonal analysis and climate scenarios as well, just to see how the seasonal changes would occur. And all of this work was really kind of supervised by Ben Jengalewski. Ben is from Southern Illinois University. He's an emeritus professor there, and he has helped us over the past decade on these kinds of projects, water demand forecasting projects. And just for kind of everyone's information, one of the findings of this is that the surface water in the Central Indiana region makes up much more than half of the water that's used. And most people think of Central Indiana as having a kind of a groundwater or based on groundwater, and it's really not. There are big intakes that are used for public supply and for cooling water for power plants. And what this shows is how that water is distributed. If you follow just one of the paths of the groundwater, which is the darker third in that largest circle, you can see that groundwater, most all of it comes from the outwash aquifer, the one that kind of parallels the White River through the region. And so this infographic kind of illustrates not just which source is being used, but who's using that water for what purpose. So groundwater is dominantly blue. That's the public supply. And surface water is largely used for public supply, but also for industrial purposes. So it's good to think about where the water is coming from and who's using it too for these different purposes. So one of the findings that is kind of a grand conclusion of the water availability, or excuse me, the water demand forecast, is that today we use on average about 385 million gallons a day over this 9-county region. And that includes all these sectors, just as I mentioned before. And in 2070, that will be just under 500 million gallons a day. So a 100 million gallon per day increase over 50 years. So 2 million gallons a day per year over that period. What's interesting, I think, for most people is to look inside of each county and realize that a lot of the water is being used for things besides public supply. A lot of people imagine that most of the water use is being used for drinking, and it's a lot of water is used for that, but there are other big users. So there are power generation in Marion County and Morgan County historically, very little agricultural irrigation except in Shelby County and some in Morgan County. And public supply does dominate in most of the outlying suburban counties. But again, the question is 100 million gallons per day is going to be needed. Where will it be? Where in this region will that additional water be needed for growth? So if we only look at the public supply piece, the drinking water side, this map shows the public supply withdrawals for the entire region, showing the service areas for the different water utilities, and the color code corresponds to how much more they will use in the future in this forecast versus what they use today. And the conclusion here is pretty straightforward, that public supply withdrawals in the counties around the city are going to increase, but they're really going to increase most in Hamilton County, where their projection is for a 100% increase in water demand in Hamilton County. So a lot of the need is going to be there relative to current use. So yeah, that's good to know. It's good to know how much more we will need. But now that we've broken it out and we have some understanding of where the water is going to be needed, the next question is the water there to be used or found and developed? So the phase 3 of this project, the water availability report, really was done to answer that question. How much is there and how much can we, have access to? So I'm going to talk about the methods that we used, the data sources that we relied on for the work, the definitions that help define the terms that help bound the work itself, and then I'll describe some of the findings. And I'm going to ask Eric and Teresa to just jump in if there's anything that you want to correct or change. This diagram really just shows the project scope that we had and how we performed the work. It illustrates all of the different elements of the water availability investigation. On the left-hand side, you can see there's different models and tools that we developed, and we used those tools, and we had databases at the beginning to drive through to get to the regional scale and then more local scale further to the right. And what's kind of key to this conversation is I'm really going to be focusing on this water availability model and what are the methods we use there for this. In this region, we have 25 USGS daily records, stream gauges that are in the region. We also have this significant water withdrawal facilities database that was mentioned before. We have monthly data from 85 to 2017 for that, at the time of this report. And we also had access to the US EPA's ECHO database, which is NPDES discharges into the stream. And that record only went from 2007 to 2017. And we also have reservoir operation records from 97 to 2017. But the bounding or limiting period of record was where we had NPDES discharge data. And so that became our period of record, the 11 years, including 7 and 17, for the data sets that we used. And so the availability analysis really was bounded by that, but we had droughts, as was mentioned before, in 2007 and 12, and we're going to look at those and see how they show up basically in the record. If in that same region that was mentioned before, this illustrates the outline of the 9-county area in kind of a light amber brown color. And then it shows the 3 different basins that are drained in this area, 3 different drainage basins. We have the green in the middle is the West Fork of the White River and its tributaries. And the pink is the East Fork of the White River, and the blue flows over to the Wabash River. That's Wildcat Creek and Sugar Creek over there. And what you're looking at are the watershed drainage areas that are segregated, have basically gauges above and below them so that we can actually compute the flow through each of these sub-basins. So there's this stream gauge at the downstream end of each of those. Hang on. And so just from a kind of topological perspective, this is how the flow and the data went together. So the flow from one basin, sub-basin, flows into the other, and we had to, of course, add them up to make sure that we were accounting for the water, because that's what we're really trying to do, is do an accounting of all the water in each of these sub-basins. So I am having trouble with this top. I have a top bar across my thing that I can't really read it. This is definitions, the definition of the terms that we use. So on the left-hand side, it's the water availability is equal to the natural base flow. This is just how we had to frame the problem. I want everyone to kind of imagine this isn't really, there isn't a water availability number. You can't look it up. We have to compute this and define it for the purposes that we're working towards here. And the first thing that we know is that if it's natural base flow, of course, that's the amount of water that's in the stream, but it's the natural base flow. So we have to subtract from that the in-stream flow requirement, if there were one, like the 7Q10 or some other number, because we don't want to take from the stream that amount of water that is a kind of minimum number for the stream that's usually for ecological purposes. And you also have storage in the basin. So we can add the storage that we've put into the basin because that water could be released. So water availability is the difference between the natural base flow and in-stream flow, and then you add the storage on top of it. But the excess water availability, that is the amount that you see. What was described in the first equation is really what you see in any one basin, sub-basin. But there's something missing there because water's flowing into that basin from the upstream side. So if you want to accumulate and see how each basin, sub-basin is behaving, you actually have to see that the water availability has to further deduct the water withdrawals that are coming out in that sub-basin, but it has to add back the return flows in each sub-basin that come from the discharges from treatment plants or processed water. So in order to we went through this to compute each of these, and each of these terms is untangled and evaluated in the availability report. So the report is thick. It's a 300 plus page document, but it really explains each of these steps that we went through. So we had this limited time series, and we summarized these by quarter and by subbasin. And we looked at, for each subbasin, we had natural stream flow, the natural base flow, which we computed, the water availability, and excess availability, computed it as just defined a minute ago. And we have the cumulative excess availability, which is the added up total as from the upstream to downstream. So we have each of these computed for all of those subbasins. And here are the findings. That quarter 3 is always important because it is when the minimum availability occurs. And this kind of goes back to what Trent was saying, that the late summer and fall is really when the driest period occurs, or at least the lowest flows occur. So seasonality is important. And the minimum occurs in that quarter, and we're going to use that quarter as our reference quarter and try to answer the question of what is availability in that limiting quarter of the year, because that will give us the minimum. If we map that availability in the region, you can see something that, if you know the region, is not at all surprising. The intakes for the Indianapolis and other water supply systems are on the north side of the city. That's where the orange is, and that's where the darker, the color, the reddish color is, those two orange colors. So on the north side, you've got a lot of water being diverted into drinking water and other treatment facilities or other plants that is taken from the system. And downstream, it turns, there's more water available as you go further south, because you've got the return flows going back into the river down to the south of the city. So if you look at every individual subbasin, the colors here describe what's happening in every subbasin, whether there's a net excess or a net deficit within a subbasin. Within the river itself, it's a different question. This is the cumulative excess availability, looking at quarter 3 and in the driest year of the record that we had in our 11-year period. So again, to go back and forth, we had the 2012 quarter 3 subbasin by subbasin values. And this is what it is when you add up and include and account for the water that's flowing into that subbasin from upstream. And I think the key in this illustration is that there is adequate supply through this entire reach for serving the needs of the community that are using the water. But what's really striking is that there's a lot of water availability on the south side, because that's down below where all of the discharges happen. And so there's a net excess on the south side of the city. It's a crucial point. We come back to it here in a minute. Well, I kind of missed the opportunity here to make a cool point, but that is that if you look at these subbasins and you know the region, the fact is you can't get water anywhere within these subbasins equally. You can get water near the river, and you can get water from the aquifer that is also adjacent to the river. So if you only map the outwash aquifer system on top of these values, these water availability values, you'll see where water is not available, but where it's also accessible. And so this slide and map help you see where water is accessible and available. This is kind of a key point, again, through the document, that availability doesn't always translate directly into, oh, it's easy to get water anywhere in that panel that you're looking at. You really can get more water, higher withdrawals can be obtained closer to the river in the outwash aquifer. So we differentiate those two terms in the report and talk about the difference between availability and accessibility. So when you look at the outwash, you can see the clusters of wells that are, I indicated here with the dots. And you can also see the purple down to the southwestern corner in Morgan County is really just because we don't have a gauge below that to add into this. It's so far below. But basically, hundreds of millions of gallons a day, excess availability, are on the south side of Indianapolis as it flows into Morgan County. So there's a lot of water availability within the region that can supply more than the total need that exists in the region. And one of the findings that we came up with that just fell out of this work was that the wastewater side, the discharged water into the streams, is incredibly important to our region, to the central Indiana region. And that is partly just because there's so many people there, and the increases in public withdrawals are really offset by these increases in wastewater treatment plant discharges. Again, folks don't understand the fact that when you have a big intake on the river, that a lot of that water goes back into the river just downstream. And that's actually how the city works. There's some fraction that's taken away, that's evapotranspirated or used in other ways that consumes the water. But most of the water goes back through the treatment plant into the river again, further downstream. Wastewater treatment is critical for water availability. So the treatment and the quality of treatment and the quality of that discharge are very important to the region. They depend on that for water availability. And it's kind of significant. In the graph here, you can see that the withdrawals for public supply and the returns at the wastewater treatment plant, really withdrawals are matched by the returns for the high demand periods. So we really do depend on that discharge. Another finding is that again, I can't really read this. The effects of mining in the area in Hamilton County where rock mining is happening, as well as the mining of the sands and gravels of the aquifer, there are places where it's obviously competitive. Some of the water use in the area from the mining dewatering is really affecting, or could affect, the water availability from other users. That is mostly drinking water utilities. So there's competition between these high capacity significant water withdrawal facilities. And at some point, I mean, there could be, with more data, there might need to be action taken to understand better, or to correct if there were a drought and it needed to be, water use had to be prioritized in the area. Another finding is that the Hamilton County really is in this pinch point where it's the fast growing community with, fortunately, a lot of good water supply, but it relies on water from upstream. So it really needs that water to continue to flow downstream towards it. There's this rapid growth that's happening for purely socioeconomic demographic reasons, and that's a good thing for the county. And there's an increasing demand for public supply, and different utilities are actually exploiting and working in those different aquifers there in Hamilton County. So that, along with this last bullet, that there's increasing mining and the withdrawals that go with it, it's kind of in this conflict zone of demand for water supply. So if we looked at the growth that is anticipated, the future is that a lot of more water will be coming out of this panel, this orange panel that's on the north side, the sub-basin in Hamilton County that's butterfly shaped or whatever. It has two wings on it. There's more water going to be produced there, but that additional production and those additional that additional drinking water will be discharged again downstream as you go further down the river. And one other feature that's built into this is the fact that there's been this deep tunnel project that can help produce, I think, more treated water, and none of the combined sewer overflow water is really going to be a part of the system as much as it has been in the past. So there's going to be an improvement in quality, as well as this change in where water is available. So again, this is really about the fact that as water levels or water use increases, so does the discharge, and that's really where the region has to be thinking. So the reports, the full reports, are available on the Indiana Finance Authority website. Questions can go to either in the chat here or to Sarah Hudson, who's on this call, and or myself, either one.
All right. Thanks, Jack. Sounds like a lot of work has gone into this. And I know when I first started my position a couple of years ago, you guys were kind of in early phases. So it's pretty cool to see how much progress has been done.
Thank you.
So can you expand a little bit more about studies around the state and perhaps integrating drought with those studies? Drought risk?
Yes. So again, the broad reference to other studies that I mentioned includes work that was done in the water demand forecast to look at the changes and the effects of climate change on the water demand, because the idea is that their seasonal effects are also important, but how will those seasonal effects be altered in future climate conditions? So we looked at a variety of climate change forecasts and evaluated those, and actually decided, after looking at all the different data, that we probably were working, there wasn't much of an argument for a dramatic change in climate. This is really, I think, again, consistent with what Trent was mentioning before. We couldn't point to anything and say, look how badly it's going. The last 30 years have been wet, and we had a hard time arguing to ourselves that it's going to be much drier. So seasonality may change, but it really didn't alter the real driver, which we saw as being population growth in the regions.
Interesting. Yeah, because I would think, if you look historically, I would assume fewer people in Indiana, so maybe it wasn't an issue. So now that we don't think drought is going to be that severe, perhaps we still have more people. We have more people drawing from the water, but even in the northern part of the state, where more and more farming production is going into irrigation as opposed to rain dances, if you will, how is that going to impact even the downstream stuff that is coming into the area?
And I think that ends up being the real key question is in this area, this is it's the most urban part of the state. And so the mix of uses is representative of this part of the state. If you go to the north or even to the southeast and go towards Bartholomew County, where they've had explosions of agricultural irrigation, it's a different story. It's not the same story. And the seasonal effects are different, et cetera. So the story changes when you get out of this one region. As soon as you go to the north and towards the Kankakee Basin, you end up with an entirely agriculturally driven hydrologic system. And again, in some other parts of the state, you have that more of a agricultural driven basins. And here in the middle of the state, though, it's about the utilities. Where are the utilities growing? How much do they need? And how do the discharges from the wastewater plants, how do they affect the picture?
Mm-hmm. Great. Before we take a break, for a break, oh my gosh, how many times can I say the word break? Are there any things that Eric or Sarah want to throw into what Jack or add to what Jack had said? Or are there any questions that people want to ask? And again, you can always ask questions in the chat. All right. So let's take a 15-minute break. We're just slightly behind, but I think we can catch up after the break. So I have that it's 10:35 now. If we can come back, what would that be? 10:45, 10:50. And then we'll have the last two talks of the day. We got 24 participants. That's not bad. So I'm going to try and go to the next question just for the sake of time. If I can figure out how to do that. So this one, hopefully you all have access to, is 3 different kind of sub questions. How well do you think your agency or program coordinates with other agencies or programs regarding drought preparedness, response, and reflection after the fact? And I think if you just sort of click and drag the slider for how well you agree or disagree. And actually, your responses, well, this is fun, at least in my mind, your responses are going to be taken and analyzed after this workshop and help feed into those following 2 workshops where we go more to the northern and southern part of the states. Because if folks on this kickoff meeting are thinking we're doing great on preparedness, but we're not doing so well during reflecting after the fact, I mean, this can help steer future modifications and edits of whatever drought or hazard mitigation plan is in place. Obviously, this workshop's focusing on the drought side of it. So it's looking kind of neutral-ish in a sense. I'm a little surprised by that. I was thinking well, I guess preparedness is winning, if you will, but it's not that strong. There we go. Be nice to see them all in like the 4 or 5s. But it just helps verify that's why we need to have these workshops. Got 16 participants. I still see that there's 39 participants. So if we can break the 20-person mark at least, then we can go on to the next question and then hand it over to Ryan and Manuela. Come on, 4 more people. "17 responses. 18, we're almost there. Don't put your phones away yet or your tablets. 19, we just need one more person to respond to this survey. It'll be a test of wills. Can I wait this long? I don't know if I can. All right. Hey, we did it. Thank you. Woo. All right. Next question, same idea, but now the topic is flood, not drought. And since we know we just got 20 people filling out the previous one, hopefully this one will go quickly and we'll hit 20, if not more, pretty fast. Got up to 18 already, and it looks like flood might be a little bit better coordinated than drought. 19, 20. Gosh, can we go above 20? Or is everybody like, yes, we made it to 21. I'm so excited. All right. Well, if you guys still want to fill out this survey, like I said, all of these survey results are being recorded. So if you want to think about it or get to it after the fact, you can. But for now, I think it's pretty interesting that I'm seeing that the flood had a little bit higher in terms of coordination with other agencies than I think the drought did. Ooh, 22. It's getting really exciting. But I don't want to take up any more of Ryan and Manuela's time, so I'm going to stop here. And if they want to start sharing their presentation.
Can everybody see that?
Looks great.
All right. Well, good morning, everybody. And thank you, Beth, and everyone who's had a hand in organizing what's been a really interesting set of presentations so far. I think there's a lot of good information that's coming out of the presentations, but also some of these Mentimeter questions. And the last two questions specifically show that we do probably still have some work that we can be doing as a state, not only agency level, but feds and locals and utilities and you name it. So today, Manuel Johnson and I are going to have just kind of more of a conversation with you all and each other about the types of plans that are currently existing in Indiana. Manuela, did you have any opening statements you'd like to make?
Well, I think it really shows from the Mentimeter that a number of people don't maybe necessarily know what's going on behind the scenes. And we haven't been publicizing our drought activities as heavily as we have the flood events. So I think it would be great probably to start off and tell folks a little bit about what we've got. What do you think?
I think so too. So without further ado, we're going to start by talking about the Indiana's water shortage plan. This plan is what I consider a relatively young plan. It's less than about 30 years old. There may be several folks who have participated in helping develop this plan and having conversations over time, but just a real general overview of the history of this. You heard Trent mention earlier that some of these years keep popping up, 1980, 1988, obviously 2012. And so the water shortage plan really formed after some of the dry years in 1988. The first water shortage plan was officially created in 1994, and this was really not only the Department of Natural Resources, but a lot of collaboration with folks like DHS, and then a broad array of stakeholders. In 2006, there was actually some legislation that enabled a water shortage task force. And the director of DNR at the time appointed people from about 10 different water use sectors. And this is everything from both water and wastewater utilities to environmental groups, industry, agricultural, academia, and then the various agencies who participate in a lot of these types of discussions. And it just kind of goes to show how broad water really affects so many elements of not only government, but our water users in general. The last time this plan was updated was in 2015. So we've definitely seen some dry periods since then. And maybe one of the questions we have at the end of this is it time to update this plan again? And so just to give a real brief overview, really the overall goal of the water shortage plan was to identify and coordinate what I'll call the drought management responsibilities and actions across a lot of the different agencies. And really, what are we trying to do here? We're trying to protect human health, safety, and welfare first and foremost. We're really trying to preserve some of the essential water uses. So as we start to see shortage, how do we prioritize these uses? And then obviously there's a lot of emphasis in at least Indiana's water shortage plan placed on water conservation, especially as the drought continues to progress. What really triggers certain levels of conservation and really reduction of use? If you haven't seen the plan before, one of the Mentimeter questions asked, is there a drought response plan? There's a couple no's, there's a couple I don't have any clues. There's a handy dandy link at the bottom of this page, and you can go check out what's in the water shortage plan. A couple other things that are in the plan also deal with some of the tools that are available. And those tools are not only for large water users, utilities and others, but really just in our own households. How can we reduce water voluntarily when there are shortages? So the plan is really meant to start at the individual level and work its way up through users and government as a whole.
Ryan, one of the things that came up frequently is that whenever we had a drought event in the past, we used to drag out what we used to call down at DHS the drought plan, the water shortage plan. And the minute you touched it and either went to update it or to just look at it because we were getting dry, lo and behold, we'd end up with a flood. So we called it the water guarantee flood plan. So just some thoughts to keep in mind there.
I think it's 80% chance of rain tomorrow. So really, and I think Trent had touched on a lot of this. There are a lot of different indicators or indices that we use to evaluate when we're approaching drought or when there is a shortage. And so I don't want to belabor this, but really the plan landed on these three: the 1 month SPI, conditions below what I'll call the normal condition in the U.S. drought monitor. So as soon as we start to see abnormally dry conditions, that's really when the plan starts to activate itself. And then obviously stream flow percentiles, when those start to get below normal. So if you look in the plan, I believe it's table 1, you'll see as we move through the different phases of the drought plan, these indices are tied to those phases. And as I mentioned, once dryness begins, a lot of the phases have to do with alerting the public, in our case, alerting the governor's office and others, so that we do start to not only kind of get on the radar that things are dry, but we get the word out and we start to say that, right now, people need to just be aware. So in that watch phase of drought, which is again defined by those indices, the plan recommends that about 5% of water use be reduced. And again, these are voluntary conservation measures with some of the practices defined. As we get drier and conditions persist, and we trigger the warning phase, that's really when the alert goes to more, let's start preparing for that imminent water shortage condition. Let's start coordinating among these agencies and really take it to the next level. And what the plan again prescribes or recommends, not necessarily prescribes, is additional water conservation measures up to 15% in this case. And just to put this in perspective, In 2012, the entire state, and you'll see that on the next slide, was in a warning phase. And so not only did the department send out letters to the significant water withdrawal facilities that Jack Whitman mentioned earlier, but then IDAM also started working very closely with the utilities and the public water supplies, just kind of getting a sense of how things were on the ground. So you really had quite a bit of coordination and communication with the water use community. And then finally, the emergency phase, where a minimum of 15% is recommended to conserve. This occurs under a governor's declaration. And at this point, this is when you start to actually, what I'd say, marshal all available resources to respond to this long, persistent, and emergency drought condition.
In 2012, we actually had burn bans throughout the state of Indiana, and even the July 4th festivities were canceled. And that really is a critical impact on our communities when we have celebrations that we can't enjoy. But we also, at the Department of Homeland Security, made sure that we had available additional means of moving water, including what we call Bambi buckets, which are typically used out west for the big wildland fires. But we actually had some brought here in Indiana, made available, so that we would be able to, if need be, move water from a lake or a pond to do fire extinguishment activities.
And I think, just as an aside as well, so many times we think of water shortage, and that's obviously the title of this plan, but it really goes beyond. And you saw Trent outlining the different types of drought. And in 2012, I was working in the state of Missouri at that time. And Missouri was one of the top 3 cattle producing states in the country. And folks were having to sell off entire herds because there was no food availability. The hay crops, the pastures were at zero. And so people were having to get rid of cattle because they couldn't have water, they couldn't feed them. And so it extends beyond, even going from those burn bans of 4th of July, but it really impacts just about every facet of our lives.
And especially when we shut down the water usage, we go into the water conservation efforts. We also have to look at our industries that are heavy water users.
Yeah, absolutely.
And the impacts that we have there. So it is definitely a much greater impact and environment that we need to look at, rather than just one slice or segment of our community.
I agree, and that's building on that conversation in the last slide. You can see the drought monitor from 2012, and you can see the areas of exceptional to even historic drought.
Yeah.
And this is when we started sending out those letters to over 3,600 of those water users, and that was across the board, whether that was a public water supply, an industrial user, an agricultural facility, you name it. And one of the early and I think updated portions of the water shortage plan was to start to talk about what is the priority when the water shortage is so severe that we have to start curtailing or basically prioritizing one use over the other. So we're not going to tell you everything that's in the plan, because then you won't go read it. So I'm going to leave that cliffhanger out there for you. There are also a couple tools that I think are pretty helpful within the plan. Indiana's got a suggested model ordinance. Again, these are for municipalities who may want to adopt some local controls or regulations when they start to see shortage, maybe to their small water supply system, and how to not only encourage voluntary conservation, but then maybe move into some more difficult decisions of mandatory conservation and restrictions, and unfortunately, in some cases, even water rationing if it gets that bad. And so, this is, again, there are probably many templates that can be taken for municipalities, but the plan wanted to at least provide that for communities to consider. Maybe one additional tool that the department has, and when I moved to Indiana, I was actually very, very impressed and encouraged by the level of what I'll say authority exists to help regulate water during these times of shortage. And so specifically, if we're looking at domestic groundwater users, so maybe you have a well at your home, you're a small domestic user, there are actually provisions in place that if your well would be impacted by a significant water withdrawal facility or a heavy user, that you're actually through the statutes entitled to some compensation and relief, where either that community, or excuse me, that water facility will work with you to provide an alternate temporary source of portable water. Maybe they'll drill a new well for you. Maybe they'll deepen that well. And if it gets to a point where that type of negotiation falls through, there's actually some regulations and authority the department has to restrict pumping. But we really hope that it never gets there. In fact, about 100 of these water rights investigations are conducted every year, and most are resolved between the homeowners, the domestic users, and the well that was potentially causing the problem. And I want to highlight all the work Mark Bash and Bill Davis and their staffs do on helping conduct these investigations. What's interesting though, we average 100 of them, but in 2012 we had 150 alone in June and July.
Wow,
So, yeah.
that's definitely a significant number. And I know our agency heard a lot from property owners complaining that their water levels were low in their wells, but also their ponds and lakes that they were using.
Yep. That's the backyard hydrology of looking at what stage is my pond, what stage is my creek. And so I think that's pretty important. But enough about the water shortage plan. I'm assuming that there's more we're going to talk about today here.
Yeah, definitely. And a lot of people wonder, what's Indiana Department of Homeland Security got to do with drought? And we do have a little bit of a different perspective. And a lot of that comes from the Homeland Security's roles as a whole. We monitor drought conditions on a regular basis throughout the year. And most recently, we teamed up with Department of Natural Resources, as well as members of the National Weather Service, Department of Agriculture, Purdue, the Climate Center, especially right before Beth came on board. We had a little bit of a gap there where nobody was really doing a lot of feedback to the drought monitor folks. And so we brought together this team to fill in the gap, and lo and behold, we're still up and running. And I think it's actually a modern practice so that we meet weekly whenever we have drought conditions in place, or what they call D0. And we talk through what the conditions look like, what the science is all about, and we make the recommendations on behalf of the state of Indiana as a team. And I think it really brings about a lot of good information exchange. So we also, Department of Homeland Security coordinates drought response efforts at the state level, and we coordinate state resources. So you guys lead with the drought shortage plan as far as responding to the drought itself, but our agency is there to provide the support and the coordination. And we actually, through state law, have the ability to ask other state agencies to assist where we need to, as long as those requests come through the Department of Homeland Security's Operations Center. We also have incorporated drought into the state comprehensive plan by actually just putting in an appendix that includes the state water shortage plan. So rather than creating a separate appendix on behalf of the Department of Homeland Security, we use the document from the Department of Natural Resources. We also address in our state hazard mitigation plan the issues of drought, and we'll talk about that here in a couple moments. So really working together to host and call those meetings on a monthly monthly when it's not wet. Now, when it is wet,
Manuela, do you think, I know we've talked about a lot of agencies, are there other folks that you think maybe should be part of that plan that aren't currently, or if they are, how do they, someone's interested, how do they become part of the team?
well, to
Manuela,
become part of the,
You're coming in and out, Manuela, so if you can lean in more toward the microphone, or when you're talking to Ryan, I feel like I can hear you better.
okay.
Thank you.
When we are working on the drought monitor team, folks can either reach out to myself or David Smith of DNR, and we will gladly bring along whichever organizations would like to join us. As was indicated earlier, drought is not just agricultural. And unfortunately, I think frequently we tend to focus primarily on the agricultural aspects. And this winter, we had calls throughout the entire winter because ecologically we were facing some major dryness issues. And what we have to look at is very different than what we look at during the growing season. So definitely, if you have drought impacts, if you can share information with us, we'd gladly welcome people to join in with the team. Although this is a typical view of the Emergency Operations Center, during a drought event, we typically don't staff as many people into the Emergency Operations Center, but nonetheless, we do bring together the agencies who are most impacted or have the greatest responsibility. IDEM, Department of Homeland Security, Department of Natural Resources. If we need to bring the Indiana Finance Authority in, Indiana Geological Survey, various organizations, the Climate Office, we would bring those all together to discuss the situation and to look at ways that we can resolve, move forward, address the impacts that exist. The hazard mitigation plan really is required both at the state level, but also at every county level. And if a county wants to receive disaster assistance from FEMA through any of the programs that are listed there, or any mitigation funding through FEMA, this plan has to be in place, and it has to address all the risks and hazards. And so Indiana has included a mitigation plan, past drought profiles. We look at future conditions as well, what changes are coming. So we really appreciate all the information from earlier today. You'll probably see some of your work showing up in the next iteration of the mitigation plan. And we set mitigation goals for the state of Indiana, both based on county feedback as well as what we see as overarching needs for the state. And so if you're interested in seeing the drought portion, please feel free to jump in and grab the Indiana State Mitigation Plan from the Homeland Security website. We've given you the link below, but also if you need anything, you can always give one of us a call and we'll gladly share that information. Anything you can think of, Brian?
Well, my only question was, I noticed the plan says 2019. How frequently do you guys update the plan?
The plan has to be updated every 5 years, and every 3 years is another cycle for the counties. And they've been updating those cycles to try and bring everybody onto a similar schedule. So we want to thank everybody for listening in on our conversation about how we're coordinating efforts, and we'd love to hear where everybody thinks we need to be in the future. So Beth, we are going to turn it over to you. So
All right. That was absolutely adorable. I loved the style that you had with the back and forth. I had a smile on my face throughout the whole thing. So thank you for not only making it informative, but entertaining at the same time. We probably have a minute or two. If folks have any questions, either you can unmute yourself and ask the question, or if you want to put it in the chat. So I guess the answer to the question of does Indiana have a drought plan is yes. Or water shortage plan, you know, it's all kind of the same scope.
I'll just say that you know, having worked in 2 different states and have participated in some of the dues workshops that I know Molly has been involved with, you know, I think states always do a good job with response. I think it's the proactive early warning pieces that I think all states can still work on. And you know, just going back to the importance of data, like the soil moisture networks Trent was talking about, or the USGS stream gauges and groundwater monitoring wells, and just kind of having those integrated hydrologic networks where we can see the whole picture and become more proactive. You know, that's where I'd like to see maybe, you know, as these plans advance, they become more proactive.
Mm-hmm.
For hosting the Oscars next week.
Yeah, definitely. Well, Ryan and Manuela, if you don't mind, you had a couple links, URLs in your presentations. If it's possible, can you copy and put those in the in the chat for everyone? And then that way we can maybe copy them and put them aside if we want to look at them later. And then in the meantime, our last presenter for the day is Cody Knudsen from the National Drought Mitigation Center, who will be telling us about what other states are doing. So Cody, if you want to share your screen.
Sure. Hi, everyone. Let me adjust my camera just a little bit. Sounds like everybody's having a good day there. And I'm going to share my screen. There we go.
It's looking
Can
good.
everyone see that and hear me all right?
Yep.
Okay, great. Yeah, my name is Cody Knudsen, and I head up the drought planning program at the National Drought Mitigation Center, or based at the University of Nebraska in Lincoln. And I was asked just to talk a little bit about some new developments in state drought planning. So we work with states across the country, and these are just a few of my observations about the latest things that people are talking about. And they're in a little bit of an order here. But I wanted to give a little background first. You know, one of the things is that one of the trends is that people are developing drought plans. They're developing more states are developing them. And you can see down on the left-hand bottom left, 1982, there were only 3 states that had drought plans. And those were drought response plans. Now, as you go through the years, you'll see Montana was the first to develop a mitigation plan in 1995. And now by 2020, I put 2020 just because the map's a little outdated. Alabama has a drought plan now as well. But there are 47 states have some type of a drought plan. Now, most of these have at least a drought response plan. But again, the latest trend is for people to develop a drought mitigation and response plan. So not only the response plan would cover what to do during a drought, now people, as they develop drought plans, an increasing number of them are talking about preparedness. What can you do before drought occurs to be better prepared and more resilient when drought eventually occurs? So they'll outline what agencies are going to do before drought, and as the drought develops, what other types of response measures are they going to undertake? So something to keep in mind if you're thinking about updating your plan, focusing on mitigation and response, perhaps. And as Ryan and Manuela talked about, not only are people addressing drought through a drought plan, or in your case, the water shortage plan, but also through hazard mitigation plans that you talked about, through state water plans. Some states have a state climate plan. So there's a variety of different plans that you can use to address drought. And on the right here, this image is on our website. We have a section called Information by State. And you can click on each of these states and it will provide access to their state drought plan, their hazard plan, their water plan, or their climate plan, just to make it a little bit easier for states to see what other states are doing. A little more easier access to those plans. And I'm going to go to the next slide and I'll explain these plans a little bit, these colors schemes here. So we had people, our staff at our center went through these plans and identified whether or not they incorporated drought. You can see the top left, those are the state drought plans. The ones in blue, we considered them to be more drought response plans. And the ones in green were more drought mitigation and response plans. And as you can see here, we have Indiana as a drought response plan, even though there is some mention up front about some long-term water conservation measures. I think the reason, and Kelly Smith is on the line here too, she can answer some questions after my talk here about how they classified these. But it didn't really outline the agencies who specifically was going to do these mitigation actions on a long-term basis. Is probably one of the reasons why it's classified as a drought response plan. And under the state water plans, top right, anything in blue are the states that we didn't think really didn't incorporate drought to a large extent. But you can see most of the state water plans or the state water policies did incorporate drought. The same with the state hazard mitigation plans on the bottom left. Every state hazard mitigation plan included drought as one of their hazards of concern that the state should deal with. Now on the bottom right, the state climate plans, not every state has a climate plan, but the ones that did, they all incorporated drought as well. So as Ryan and Manuela talked about, there's more than one way to address drought. There's more than one plan type to address drought. And it's important for coordination, but a little bit later I'll talk about it's also important for funding that you mentioned. You may be able to address drought through FEMA, get some money from FEMA for the hazard mitigation plans, from the state for your state water plan, or for your state drought plan, et cetera. So it's important to coordinate your efforts, and that's just what people are starting to do more and more. In the past, you might have seen that they have a state hazard mitigation plan or a state drought plan or a water plan, but they didn't necessarily talk to each other. Maybe to some extent, but it wasn't intentional. Now, for example, Colorado, they've been working on drought plans for a long time. Since 1986 is when they first developed their first one, and they've been modifying it every few years ever since. But in the later years, what they've done is they have made it their drought plan. They have a state drought mitigation and response plan, but they have made it as an annex to, or an appendix to, their natural hazard mitigation plan and their state emergency operations plan. So you'll have each of those plans, and at the end say for example, their state hazard mitigation plan. It discusses the whole suite of hazards that they're trying to deal with, including drought. But then at the end, they'll have an appendix or an annex that talks about drought in detail. And it's not just about hazard mitigation, but hazard mitigation and response. Same thing with their state emergency operations plan. They'll talk about how they're going to handle all the hazards. And then at the end, there will be an annex, the same annex, talking more in detail about drought. But what that means, though, is that it has to meet the requirements of those other plans. So as they're putting their state drought mitigation response plan together, if they're going to have it as an annex to their hazard mitigation plan, it has to meet the requirements of FEMA in putting a plan together, a drought plan. Same thing with the emergency operations plan, just something to keep in mind that as you start tying plans together, you may have to meet some of the requirements of putting those other plans. When you're developing those plans, you need to meet the requirements when doing so. But that's kind of one of the latest trends, is they're trying to get the plans to talk to each other. to make sure they complement one another. And they may even include the exact same mitigation measures, for example, like in Nebraska. We have a state hazard mitigation plan, also a state drought plan. They're almost identical. The information from the state drought plan, the mitigation section, they pluck it out of there and put it into the state hazard mitigation plan. And whenever they update one of them, they take that information and put it in the other one. They're just making sure they talk to one another. So that's one trend, or another trend, I guess. So one, people are developing more plans. They're increasingly incorporating mitigation. They're tying those plans together. And since, like in Colorado's example, and it sounds like in Indiana's, you've been updating these plans over time. They're starting to get more lessons learned and revising those plans as they go and making them be more realistic and, I would say, doable for the state agencies. For example, this is New Mexico. Now, New Mexico first developed a state drought plan in 2004. And as you can see, this is their declaration matrix, how they're going to declare stages of drought. They had a normal stage, advisory, alert, warning, emergency. That's going into drought, and then backing out of drought, you would go back down through these stages. Well, each of these stages are supposed to activate some type of response. And that's one issue they had, but also how they activated them was somewhat complicated. They used the standardized precipitation index, they used the Palmer drought severity index, and they had different values depending on if it was a short-term intense drought or a long-term, more moderate drought that added up, accumulated over time. So it was kind of complicated, and they had a lot of stages. So they found it to be somewhat difficult to implement. As they started experiencing droughts and tried to implement this plan, they found it somewhat difficult for a variety of reasons. One is they said that it wasn't realistic for their state agencies to meet that often. They're fairly dry anyway. They've been in drought for quite a while. So the state agencies really didn't get together much until it became pretty severe. And so that caused problems though, if the state agencies, if they missed a step. Say, I'm gonna back up one here. There we go. If, for example, it was getting somewhat dry, but they didn't really meet until you got to the alert stage. Well, people might be saying, well, you skipped a stage, or we're in alert and you should have been meeting under advisory. What was going on? The state didn't know what they were doing. They weren't keeping tabs. And so they want to avoid that. And so they said, this is more realistic for us. We have a watch stage. We don't even have a normal stage. We're always watching for drought. And we'll meet when it gets to an emergency or exceptional stage. That's more realistic for us as a group to get together, our task force, and talk about these, the problems going on. And two, they had like I said, they had a fairly complicated system for monitoring drought to activate these stages. So they decided to go with one primary indicator to activate drought. Not that they won't look at other indicators, but the primary one that they're going to look at is the US Drought Monitor. Now, most of you have probably seen that on the news or in the papers. It's a snapshot of drought conditions across the country that's put out every week. Now, a lot of states, what they'll do is they have people that get together every week and they provide input to the US Drought Monitor authors. And New Mexico is one of those that they meet every week. And they talk about drought conditions in the state. They provide their recommendations to the national drought authors. So what they decided was that they put enough input into monitoring their conditions every week and providing input to the National Drought Monitor map that they trusted. And they're putting all this energy into it. They said, why don't we just use it? And so that's what they decided to use instead of, instead of using the other system. They're primarily relying on the US Drought Monitor, but they'll also look at other indicators as well. But this is the primary one. And they thought by reducing the number of stages, simplifying the drought declaration process, that was going to be more realistic for them based on their past experiences in dealing with drought. Now, as they go forward, they'll see how this works. This was updated in 2018. And as they start to experiencing droughts, because some people have criticized this a little bit as maybe being a little too simplistic and not really meeting until you hit an emergency phase. Some people question that a bit, but we'll see how it works for New Mexico. That's really what it's all about, is just getting something that works for you. Okay, now I think this was talked about in the last presentation as well, is that data. Now, Ryan, I think you had mentioned the monitoring data, how important that is, but there's also more data available about impact and vulnerability assessments, about evaluating mitigation and response strategies. You'll see down in the left-hand corner, we call this the 3 pillars of drought risk management, or developing a plan or a policy. You need to establish a monitoring and early warning system, undertake an impact and vulnerability assessment to understand the problems or issues associated with drought. Some people might call this risk assessment. And you can use that to identify effective mitigation and response actions. And so I would say one of the advancements in the last decade or so is that people have really put more science and data into their impact and vulnerability assessments. There's more data and tools out there to do that as well. But, you know, I would say 20 years ago, when people are doing assessment, they might have just said, yeah, you know, we're vulnerable to drought. We have some fish kills, our streams might be vulnerable. We have some agricultural losses. If they had any data, it might be in ag. We have some tourism losses, but they were very generic. Well, now people are trying to put data behind those numbers, put some numbers to those. Descriptions are great, but numbers are great as well. And if you're looking for examples, I would probably point to South Dakota. South Dakota recently developed a hazard mitigation plan. It's not necessarily redoing their response plan, but it was their mitigation plan. And this was part of their hazard mitigation process as well. I think it was even funded by FEMA money. But what they did is they looked at historical data about drought impacts within the state. They mapped them. This was from the US Drought Impact Reporter, one of our tools that's a daily archive of drought impacts across the country. They took that data and mapped it, but they looked at all kinds of data. So they provided data and numbers on drought impacts when they had it. And when they didn't, they provided a pretty good narrative, a description. They didn't go overboard trying to provide data for every type of impact. They just described it when they didn't have good data. But when they did, they provided the data. Hawaii is another interesting one where they tried to do some mapping, doing some overlays, putting this is where we normally get our precipitation. This is where our groundwater is at, our surface water and our population and our agricultural zones. And they did some overlays trying to see where those things intercept to come up with a water supply drought risk map. Another one is Colorado is probably the golden example. And they looked at all kinds of data, provided all kinds of maps. And the only concern I would have showing that to everybody to do the same thing is that they probably spent as much on their impact and vulnerability assessment as other people do on their entire plan. So they hired consultants and they did a lot of work, put a lot of work into it. So they have some very good vulnerability assessments, but it was pretty pricey as well. I thought South Dakota was a great middle ground. Like I said, they provided data when they had it, and when they didn't, they provided good narratives, and others like Hawaii as well. So what all that turns into, though, is the more data you have, the better understanding and communication of those vulnerabilities that you can provide. And that'll just allow you to make better decisions. And I want to just give a little plug here, talking about the drought mitigation section as well. So when NIDIS was, Ryan, you mentioned the DEWS activities that Molly's been involved with. When she was looking into asking people in the Midwest some of their needs around drought planning, people had said that it's difficult to identify drought mitigation actions for their plans. And so we have a project going with them right now. We're looking at all of the states in the Midwest, looking at their hazard plans, their water plans, and their drought plans, and pulling out all of those mitigation actions that they have identified in those plans and putting them into a database. And we're dividing those into sectors: farming, livestock production, water, fire, for example. And then we're going to start doing an evaluation of, okay, what are all the actions that states are promoting or advocating for in their plans? And how are they different? How are actions in their hazard plans different from their water plans and their drought plans? So one, will have a database, and two, will have some type of analysis looking at these mitigation actions. And we should have this finished. The plan is by this fall. So I don't know what your timeline is for your planning, but we might have some more information on some example mitigation actions that others are including in their plans for you to look at or evaluate. And I just have a couple more. I'm not sure what my time is here, but people are trying to make their planning a little more interactive. One, they're planning, but after you have a plan developed, the testing of that plan interactive as well. So they have these drought scenario-based exercises. And there's different types that you can include or that people have done. You could do something really simple, like a tabletop exercise. So the picture on the bottom left is one we did with the Wallapai tribe and down in Arizona. And they had a plan and they wanted to evaluate it. So we brought the people that had a role in the plan, people that had actions identified to them within the plan. We brought them in to the meeting and we just gave them some scenarios. We said, okay, this is what the climate is doing, the rainfall, your snowpack, your groundwater, your surface water. According to your plan, what stage should you be in and who should be doing what? And would you be able to do that? And they found that pretty interesting because some people didn't know they had a plan. And so they were kind of brought in. So they're thumbing through the plan, looking into seeing what their agency was supposed to be doing during the next drought. And in some cases, they said, well, okay, I'm supposed to do this. I can't possibly do this. It says I'm supposed to haul water during the next drought. I don't have a truck. I can't haul water. So as they're going through this, they started understanding a little bit about their plan, the shortcomings of their plan. And the next thing they said was, well, we need to modify this. It's not going to work. In certain activities, we're not going to work. So I think at the beginning, people were a little hesitant about doing it. And by the end, they were pretty engaged and found it pretty interesting. Another one, top right, is gaming exercises or drought tournaments. These have been held in Colorado, Kansas, Iowa, Oklahoma, maybe others. They're not coming to my mind right now, but what this is more of a, so far it's been more of an educational tool. If you're starting to think about drought planning, you develop teams, you bring people in from different sectors and you might mix them up and put teams together. So you might have environmentalists and oil production and water on the same team. It just gets people talking. And these you can have a fictional basin, doesn't even have to be real. Some people might like it to be real. Some people might like it to be a fictional setting. But you bring people in and you say, okay, this is your setting. This is your drought. These are some management options available to you. This is how much they would cost. What would you do during this next drought? And each team can do that. And you can see Mike Hayes here is in the striped official shirt. You judge them on how well they did, how well they planned this. And there's prizes and things like that. So it's a game. And so it's one way to get these people who know these sectors and agencies who maybe wouldn't talk normally together in a competitive environment that's more of a game simulation, and just to get them thinking about drought. And the other type down at the bottom right, the operation simulations, that might be if you have a plan, say for a watersheds, and you want to take it through an actual simulation. The Potomac River Basin, they do this every year, where they run them through scenarios and say, okay, if this was to happen, run this through all your models. Who gets shut off of water? How much do they have to reduce? Those sorts of issues. But it's more of a real world scenario. And they do it every year. So that's another option. So there's a variety of ways to do that. But in terms of developing a state plan, Washington State, I think, was the first plan that I've seen that actually put this into their plan that they will do drought scenarios. It says every 2 years, they will do some type of a drought scenario. It could be seminars, workshops, tabletop exercises, and they're to ensure the capabilities and actions outlined in the plan are able to be effectively accomplished. And they'll be carried out by Washington Emergency Management Division's exercise and training section, which a lot of people will have, a lot of states would have some type of a training section for planning. But I thought that was pretty interesting. One of the few, or the only state that I know of that included that in there. A lot of people say in their plan that they'll be updated every 5 years or after a significant drought, but I haven't seen them where they say they're going to be doing drought scenario exercises. And because we've been doing more of these and there's more of a demand for them, there is a drought scenario based exercise reference document that's been put out by our center along with NIDIS, the National Integrated Drought Information System. And it's on our website down below there. And that can be put in the chat too, or you can just Google drought scenario exercise reference document. It's on our website. And what it does is it talks about drought benefits and preparation, types of exercises, what you should consider when putting an exercise together, the process of doing it, and some examples of past exercises that have been carried out. But those are increasingly popular. And the last thing is money. There's been more money towards drought mitigation and planning. This is an example from FEMA. So historically, FEMA didn't have a huge hand in drought, but they've been increasingly doing so. And in 2015, what they did is they looked at a variety of mitigation measures for drought specifically and ran all the cost benefits on them and did all the evaluation. And they came out with several mitigation measures that they would fund or potentially fund if you put in an application for them in terms of hazard mitigation in their hazard mitigation program. And so some of those were the aquifer storage and recovery, pumping water underground and pulling it out when you need it for communities, flood water diversion and storage, those could be reservoirs, wetlands, floodplain and stream restoration, digging out your streams, unstraightening your streams, putting the meanders back into them. These would help during flood to control waters during flooding events, but also make more water available during drought. And so those were a few of the ones that they were pushing starting back in 2015 for their pre-disaster mitigation program. So FEMA will, their big bunch of money is you have a disaster, there's money available to rebuild and rebuild better, but there's also the pre-disaster mitigation program, and there's always less money in that program. And so now what they're trying to do though is increase the amount of money in their pre-disaster mitigation program. And you can see the funding increase is going up over time, especially with the Building Resilient Infrastructure and Communities program, their BRIC program is providing more money for the pre-disaster mitigation program. And that it'll vary year to year. It's based on how much the damages you had the previous year from disasters, or the money they provided from disasters the previous year, it's like 6%. But it's estimated it will be about $300 to $500 million a year going forward. And so you can see in 2017, the pre-disaster mitigation program, there's 90 million. Then it went up to 250 million. And this last year it was $500 million available. That just closed at the end of January for this year, but be on the lookout for that again next year. So the good news is there was more money available for mitigation. Now on the downside, because there's more money available, more people put in requests for it. So they had a record number of applications for it. And as you can see, $500 million was available, and there were 3.6 billion in requested applications. So there's a large demand for mitigation money. There's more money, but there's a bigger demand. But hopefully, as people become a little more saturated in the future, there'll be more opportunities open. So I guess I would say in sum, I think there's an increasing amount of data to work with, tools to provide that data, funding, and example plans to support planning to look at. And again, if you go to our website and look at information by state, you can look at across the country, people's drought plans, their hazard plans, water plans, climate plans. all these are available to look at to serve as examples. And that's all I've got for now. Happy to try to answer any questions.
Thank you, Cody. Great presentation. It was a great way to tie up today's workshop for sure. Does anyone have any questions for Cody? You can either unmute or put it in the chat box. I know sometimes we work in silos, if you will, where, you know, we kind of are doing things the way we've always done them. And I think it's very useful to see how other states are tackling problems. And maybe at the end of the day, we realize we're doing okay. Like Ryan said prior to you, comparing Indiana and with Missouri, there's a lot of good coordinated effort within Indiana, but I'm sure there's room for improvement.
Mhm. Yeah, yesterday when I was getting ready for this too, I glanced through Indiana's documents and you know, there's a lot of great information in there. It's just, you know, is it time to look at them to see if things are still, if there's any improvements you can make, or if the actions are still feasible, and if there's any additions people want to add in new projects.
Yeah. Well, another thing I really like about your talk is it did tie in what was said earlier, where, you know, drought, Trent started off with the day saying that you can't really define drought because it means something different to everybody. It means something different in their world. What drought is in New Mexico is very different than what it's going to be in Indiana. And even within Indiana, it's going to be very different what it means in downtown Indianapolis versus what it means for a farmer up north. So we really got to think about all of those differences and what are the most important impacts. And when putting together a water shortage plan or a drought plan, you know, what type of drought are we thinking about? What are the impacts that are most important to Indiana? And then Jack talked about all the data that they were looking at and the mapping for the Central Indiana water study. And kind of there's some promising news that they learned from it, as it sounded like there's water available and most of it is hopefully accessible. But to think about applying that elsewhere around the state to try and identify spatial, geographic gaps in the information, knowing then after the break that Indiana has these drought plans, water shortage plans. And then you were brought up the drought scenario exercises too at the end, which is interesting because tomorrow, we're not going to be doing one of the drought scenario exercises, but in looking through the website, and Kelly Smith put one of the websites up in the chat, if people wanted to learn more about it, there is certainly preparatory efforts that need to be done before doing these scenario exercises. Right. And because this is really the kickoff meeting for hopefully future efforts, we're going to go through a couple of those exercises tomorrow. And this is where we really hope to hear from many of you. I know today was a very listen to presentations mode, but tomorrow we're going to want to really hear from as many of you as possible of what are the impacts you're feeling? What are the things you're most concerned about if we were in anywhere from abnormally dry up to exceptional drought levels? And then how do we prioritize those impacts so that we can either translate the prioritization of those impacts and challenges that we face with that to a drought scenario exercise, whether it's tabletop or a game or something like that, or how do we even take that information and integrate it in the next version of the state water shortage plan? So if you're curious to learn more about that, I really encourage everyone to tune in tomorrow. I don't see that there's any new questions in the chat for Cody, but he has his email on the slide, or you can somehow get in touch with him. I see there.
Yeah, if you send an email to the email on the slide there, it can be forwarded. It'll be forwarded to me too.
They know how to find you.
Yes, they do. They do. Yeah, when it comes to the plans, really, it is what works for the state. Some are very simple. Some are complicated. You mentioned even within a state, agricultural versus urban drought. Like in Hawaii, they have different indicators for ag declarations versus water resources. Some plans have them broken up by state or by region within a state, so they can make declarations by region or by groups of counties within a region. So it's really just what's going to work for the state, what people are comfortable with.
Yeah, we've been trying to wrap our head around that of after this kickoff meeting, do we now have like a sub-state meeting for the northern part of the state and the southern part of the state, or would it be more advantageous to have one, say, for agriculture and extension sector, and then another one for more municipality, local town policies and so forth for their water supply? And maybe that would be a better way to separate them out, because the ag community and extension might want to be addressing water shortages and drought from a different side than classic towns, municipalities.
Right. Or you'll see both, where they have a regional meeting and they have breakouts, or however you want to do that.
Yeah.
Yep.
So we're getting near the end of today's workshop. I wanted to ask the other members of the planning team if they have any thoughts they want to add or point out. Quiet all around. All right. Well, I don't know if I have anything else to add. So thank you, Cody and Jack and Trent and Ryan and Manuela. You all were fantastic today in setting the stage for the situation of drought in the state, where we want to go next, where we might want to go next, because we don't have all the answers at this point. But I do encourage you all to tune back in tomorrow, 9 a.m. Eastern, where we're going to really dive into the specifics of Indiana. What are the impacts that we have seen in recent droughts that maybe we should try and prioritize a little bit higher? What are the challenges? And then on day 3, we'll talk about the tools and resources like Cody and others have mentioned. There's a lot of stuff out there. Are we aware of everything that's out there? What isn't out there? So I wish you all a great rest of the day. And I, again, totally appreciate your time this morning to try and make this drought workshop for Indiana as good as it can be, certainly under Zooming conditions. Thank you.
Thanks, everyone.
Everybody.